bases. First of all, you need to memorize the strong bases. All hydroxides of group 1A are strong bases. So you just need to look at the periodic table, and you would start with lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide, cesium hydroxide. So that is from group 1A, and these are strong bases. So it's only some hydroxides of group 2A. So what I do to help me memorize the bases of group 2A is I use the term banana. So banana reminds me of barium. So that gives me barium hydroxide. And then if you look at the periodic table and you go up from barium, you would get strontium hydroxide and then go up one more, calcium hydroxide. So this to me is banana, and that's how I remember those strong bases. Let's do a problem. We're going to calculate the pH of a 5 times 10 to the minus 2 molar sodium hydroxide solution. Now you need to remember that pH plus POH equals 14. So we are given the hydroxide concentration, and we can use the formula that POH equals minus the log of the hydroxide concentration. And so then we take our molarity of our hydroxide, we put it in and solve for the POH. That gives us the POH. And then we use our formula POH plus pH equals 14. So 1.3 plus pH equals 14. We can solve for the pH and we get our answer. You also need to know some bases which do not contain hydroxide. So for example, ammonia is a classic example of a Lewis base. Look at this nice lone pair here. Remember, we have this nice electron cloud, and there's a lone pair in there, and that electron cloud has the electrons that can attack and makes this a very nice Lewis base. So you want to memorize that ammonia is a Lewis base. So if you see a molecule that's unfamiliar to you, but you see this really nice lone pair here, which we know has this nice electron cloud, you should recognize that this nitrogen is basic, and so this is not doing anything. This is the methyl part. This is the amine part. There's your nitrogen with your lone pair. So you want to recognize this as a Lewis base. And of course, you want to be able to draw the Lewis structures. Okay, so if we see a molecule like this, and we see again our nitrogen with our nice lone pair, that's the basic part of it. So we would recognize this as a base. It's a nice Lewis base. So let's say, for example, that you're given a compound you've never seen before. So here's the formula of the compound. But notice in this large formula that we have a nitrogen here, and if you were to draw the Lewis structure, you would have the lone pair electrons here. So this does have lone pair electrons on the nitrogen, so we pretty much just ignore the rest of the molecule and focus on the fact that this nitrogen has the lone pair, and this is the basic part of the molecule. So the question is asking us to set up an equation for the hydrolysis of this molecule in equilibrium expression. So when we are talking about hydrolysis, that means we're going to add water. The water is going to be liquid, and then our molecule is in water, so it's aqueous. And then remember, we have this nice lone pair here. Let's see if I can draw this. Okay, so here's our nice lone pair on our nitrogen. And that lone pair is going to attack one of the hydrogens. Remember, water can act as an acid or a base. So in this case, we have to recognize the nitrogen is acting as a base. The lone pair of the nitrogen is attacking the hydrogen. That's why we end up getting hydroxide, because the water has lost a hydrogen. And then because the lone pair on the nitrogen is attacking the hydrogen, we end up getting an extra hydrogen here, which is why we get this +1. So now that we have our equilibrium reaction, we just write the equilibrium expression. But remember, this was acting as a base. So if your molecule is acting as a base, you must call it a KB. It's really important that you label this as a KB so that you're clear that this is representing a base. So here's our products. So we just take our products and we put them on top, all of the formulas. Now remember, water is liquid, and we do not put liquids in our equilibrium expressions. So that's why you only have the molecule here in your equilibrium expression, but not the water. So again, you need to recognize in a reaction that this molecule is acting as a base. That means the water would be acting as an acid. And so if this molecule is reacting as a base, then you're going to use a KB.